Hello, so today we're going to be looking at the URLify interview problem, and this is to do with strings, and it can be found on page 90 of the book Cracking the Code Interview. So this is the problem right here. It says write a method to replace all the spaces in a string with percentage 20. So in URLs, space would be encoded as percentage 20 because spaces wouldn't be permitted in a URL address. And it says you may assume that the string has sufficient space at the end to hold the additional characters you are given. So what this means is that, for example, in this string Mr. John Smith, if we were to replace this space by percentage 20, there's two spaces here. We would need room for percentage 20, percentage 20. So we have two spaces here, but we would need an additional four spaces. We'd have percentage 20, percentage 20. So we can see that we have the additional four spaces right here. And it also says that you are given the true length of the string. So what this means is the length of the string that is meaningful. So for example here, the meaningful part of the string is this Mr. John Smith. So what we can see here is that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 characters. And that's where we get this true length value from. And if this was our input, we would want our output to be like this, where we can see that all the spaces have been replaced with percentage 20. And the string now takes up roughly the full length. It can have more extra characters at the end, I guess, but yeah, this is what that output should be. So firstly, let's think about a brute force solution. So, and the most obvious brute force solution that I can think of would be that you go through all of the characters. When you find a space, you shift all the remaining characters along by 3, and then you insert percentage 20. So if we had the string here, Mr. space John space Smith space. So we go through the string here, MR is fine. Then we get to the space here, and what we would do is we would shift these characters along by 3. So 1, 2, 3. So or we shift them along by 2, I guess, because we already have space here. So 1, 2. So this J would go here. And then space. Like this. And then we'd fill out our percentage 20. And we continue along doing this all the time. So I guess the steps are scan through string, then if not space, move to next character, if space, shift following characters by 2 spaces. So like we did here, we moved this J along 2 spaces, and then insert characters percentage 2 and 0 at scan index, so the index that we're currently at. So this is the brute force solution. So if we think about the complexity of this, so this scanning along the string, that has an order n complexity, or order s, I guess, where s is the length of the string. Yeah, I'll call this order s. S is the length of the string. So because we have to scan through each character, this is order x complexity. Now, for each character, if we were to insert space, shifting the following characters along by 2 spaces, so moving all of these characters, would also have order s complexity, which is the length of the string. So what we're doing, and in some scenarios, if our entire string was composed of spaces, for example, This, in the worst case, would have to be order S by order S. So this gives a total time complexity of order S squared. In terms of space complexity, we're not using any additional space because we're modifying the string directly. So space is just order 1. That's space. And this one is time. So this is our brute force solution. If we look at the space complexity, it's really good because it's not using any additional spaces. But the time complexity, that's not so good because we can see that we're using order S squared. And in this case, the best conceivable runtime would be order S because to do this replacement, we would have to scan through the string at least once. So the best we can look for is order S, and we haven't achieved that here. So the space complexity is fine, but the time complexity, we can improve upon that. But this is a brute force solution and it will work, so we can just lock this in for now. So one of the optimizations that we can make to this is one where we use up some extra space, but we sacrifice, we improve on the time. I'm going to show you that now. So this is going to be an optimization, and it's going to be using an additional array. So here's how this is going to work. So I'm going to write out the string again, Mr. John Smith, and then the 4 spaces after it. So what we're going to be doing is we're going to be keeping a second array underneath it. And what we can do is we can move the insertion pointer along for that array. And for example, so this is going to be our array 2. And so we scan through the characters. If it's not a space, we insert it into the new array. So we have MR. When we get to space, what we do is we do percentage, then move to the next character 2, and then move to the next character 0. And then we continue scanning and inserting. So we have Mr. John up to here. And then we have another space. So we insert a percentage, we insert a 2, we insert a 0. And then we continue writing along like this. And we can see that we have our output string. And so this is what our method is. So I'm just going to write this out. So scan through string. It should be input string really. If not space, insert character into new string array. If space, insert characters, it's going to be a percentage 2 and 0 to new string. And finally, what we need to do is we need to replace the reference to the original string with the new one. So point old string reference to new string. So for example, if this was variable s, we would need to make sure that we set s equal to this new array right here. So this is our optimized solution. So if we think about the runtime here, scanning through the string is an order n complexity. Inserting characters, if it's to the end of the string, where we don't have to insert it at a specific index, that's constant complexity because we know what index we're at and we can insert, or array insertions is order 1 complexity. If space inserting the characters 0, 2, and 0, that's also order 1 complexity because we're not shifting any characters here, we're just inserting. And this also would be order 1 complexity. So the time complexity in total will be order n, or order s, I guess, plus order 1, order 1, order 1. So this is just going to be order s complexity. And we can see that we've achieved the optimum right here because we've got order n. I'm just going to write this as order n brackets. If we think about the space complexity, we're going to be storing this additional array right here. And this array will have, at the very least, order n characters. So we need at least order n space to be able to do this. So our space complexity here is order s, or order n, I guess. And this is not the ideal space complexity because we're supposed to be, if we look at the problem again, we're supposed to be replacing in the string itself, so we shouldn't be using any more space. So this is not the ideal space complexity, but it is the ideal time complexity. And generally time would be the preferred one to be better, I guess. So I would say this is still an improvement over our brute force method. I'll write this one down as well. So this will be new array, I guess. So one thing that we're not making use of here is this information that we're given the true length of the string. So for example, we're given the number of characters where the meaningful part of the string actually ends. And this is what we can do to come up with our optimal solution. So I'm going to show you how that works first, and then I'm going to code it out. So this is going to be our optimized solution. So this will be the final solution. And you'll see why, because we managed to achieve the best runtime and space. So let's say we have our string, Mr. John Smith, and our 4 characters at the end. So the way this works is we're going to have 2 integer pointers, or index pointers, I guess. And this doesn't matter because it's constant space. The space that we use for this won't depend on the length of the string. So we'll have 2 pointers. We'll have a scan pointer and we have an insertion pointer. Now, we set the scan pointer to the true length value that we get. So in this case, 13, a takeaway 1. So we'll set this at index 12. So index 12 in this string will be this right here. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we set this, and this will naturally point to the last character right here. The insertion pointer, you will place that at the very end of the string. So it'll be the length of the string takeaway 1. So it'll be at the final index. So I'll show you how this works. So we're going to be working from the right hand side of the string and we're going to be working backwards. So what we do is we look at the scan pointer. So we examine the index of the scan pointer. We see that it's a H and it's not a space character. So we insert this at the insertion pointer right here. Then we'll move both pointers to the left. So the scan pointer is here and the insertion pointer is here. We examine this. This is a T. It's not a space, so we insert it like normal. Again, we move both pointers to the left. I insert like normal. Move both pointers to the left. We have an M, insert like normal. And then it'll be the same for S right here. Now, when we move the scan pointer to the left again, we can see that we have a space character. And what we do in this case is we will, at the insertion pointer, we'll put a 0. At the index to the left of the insertion pointer, we'll put a 2. And at the index to the left of that, so 2 left of the insertion pointer, we'll put a percentage like this. And then what we will do is we will move the insertion pointer back by 3. So we'll move it 1, 2, 3 like this. And then we also move the scan pointer 1 to the left like usual. So we get to this N here. This N is not a space, so we insert that like normal. Move our pointers back. The H is not a space, so we insert that like normal. Yeah. And then we'll move both of these back, and then we get to the O. The O is not a space, so we insert that like normal. Then we move both pointers to the left again, and we have a J, insert like normal. And here we encounter a space again. So what we're going to do is at the insertion pointer, we're going to insert a 0. At the character to the left of the insertion pointer, we're going to insert a 2. And the character to the left of that, we're going to insert a percentage. Then we move the insertion pointer back by 3. So whenever it's a space, the insertion pointer goes back by 3. And the scan pointer goes back by 1. Then again, we don't have a space here, so we insert like normal. And here we insert like normal again. And when I say insert, I don't mean insert into a new string. I just mean replace the characters in the original string. So these blue characters right here will be a modification of the original string. And this is fine because we're working backwards and we're filling in the string from the right as well. So we'll keep moving the scan points backwards and we'll still see the original characters. We won't be replacing the characters that we will need to scan later. So I'm going to just summarize this. So we're going to be place. So we're going to have place scan pointer at true length, take away 1 index. I'm just going to put this in brackets. Let's take away 1. Place insertion pointer at end of string. Then what we're going to do is scan character at insertion pointer. So what we have here is we have multiple steps. So if not space, insert or replace, I guess. Replace character at insertion. Insertion pointer. And then move scan and insertion to the left by 1. So if space we're going to insert percentage, not percentage, 0, sorry. Let me get the eraser. Insert 0 at insertion, 2 at insertion, -1% at insertion, -2, move insertion left by 3, move scan left by 1. So this is our optimal solution right here. So yeah, so I probably wouldn't code this out on the board because I'm probably just going to code it out in the editor. But if we think about the complexity for this, so if you think about time complexity, when we scan through the characters and move the pointer, this is going to be order S time complexity because we have to go through each character in the string like this. So this is going to be at least the length of the string. So this is order S. This replacing character is constant time complexity or order 1. because we know the index and we're not having to move any other characters. Moving the pointers is also order 1. Inserting 0 here is order 1. Inserting 2 at the index to the left is also order 1. And this is also order 1. And moving these pointers is also order 1 because we're moving them by a constant amount. We're not moving them based on the length of the string. So the time complexity here will be order S, where S is the length of the string. And this is our optimal time complexity. And then if we think about the space complexity here, we're replacing on the original string and we're not using a new array. I guess we should call this the replacement pointer really. Because we're replacing rather than inserting. So the space complexity here would be constant as well. So this is our optimal space complexity. So this right here is our optimal solution that we have. So we can now capture this and then print this out. So it's our final solution. Okay, so yeah, let's code this one out. So I'm going to be doing TypeScript again because that's my language of choice. One thing to note though is, like Java, I think in TypeScript, strings are immutable. So instead of a string, our function is going to be taking in a character array, but it's very similar as you soon see. So the method is called URLify, and it takes in a character array, which doesn't exist in TypeScript because the character data type doesn't exist. So it just is going to be a string array. And I'm going to call this S. So this is the input string. And it's also going to have the true length, which was this 13 here. So I'm just going to call this TL, I guess, for true length. So we have TL. And this would be an integer, but again, for TypeScript, it would be number. And it's not going to do anything. It's not going to return anything, sorry, because we're going to be modifying this original string S right here. So the first thing that we're going to be doing is we're going to be setting up our scan and our insertion pointers. I'm going to call it replacement pointer just so it makes more sense. So I'm going to say, and these have to be let because we're going to be moving the values of these. So let scan, it's going to be a number equals, and like I said, the scan pointer will be at the last meaningful character. So this will be at index of the true length of the string take away 1. So TL take away 1. Again, if this true length is 13, this is index 12 right here. And I'm also going to have replace, which is going to be our replacement or insertion pointer. And I'm going to set this to s.length take away 1. So this is going to be the last character here. And we're going to be scanning through the string with a while loop. And we want this while loop to run until the scan or the insertion pointer reaches the very left character. So that's when we know when to stop. So since we moved the scan pointer first, it makes sense to do it until the scan pointer reaches the very left to cut out an extra step. We're going to be doing this while scan is greater than or equal to 0 because the lowest index that it's going to be at is 0. So what do we want to do here? So we want to firstly scan what character we have at the string index of the scan pointer is. So I'm going to call this C, and it's going to be a string again because character doesn't exist, and it's going to be a scan. It's going to be at S at the index scan. So then what we want to do is, so we scan the character. We've done these 2 steps, so we've done step 3. So the first thing we want to do is we want to do this bit. So if it's a space, we want to insert 0, insert 2, and then insert percentage and move the insertion left by 3. So what we're doing here is if c is equal to a space character, then we want to do s at the insertion pointer or the replacement pointer, and we want to set this to 0. Then at insertion -1 or replacement -1, we want to set this to a 2, and then at replace take away 2, we want to be setting this to a percentage. So we'd be inserting 0 to percentage backwards, so it'll be percentage 20. And then we want to move the replacement pointer back by 3, so replace take away 3. This bit about moving the scan left by 1, we can see that we have this in common, so we're going to move it outside of the for loop, outside of the if statement, sorry. So then we have else, so this means the character is not a space. Then we simply want to insert that character into the replacement pointer. So s replace equals, and it's the character c right here. And then we want to move the scan and insertion or replacement left by 1. So we want to say replace equals replace take away 1. And finally, like I said, not forgetting, we have to move the scan left by 1 each time. So scan equals scan take away 1. And that should be it, really. So we've coded all of this logic now. So we don't need to return anything because, like I said, we are modifying this string directly, and I'm fairly sure that's allowed in TypeScript. So I guess we can try testing this out. So I'm going to have let s equals, the string has to be modifiable, so it needs to be s, and it's going to be an array of characters or a string array. It's going to be Mr. space John space Smith space, and since it has to be an array, we're just going to do a string split like this. So this will be a string array or an array of characters that gets passed in here. And then what we're going to have is we're going to have const true length. I want to change this from s actually and call it input string, just to make it clearer and not confuse it with this. So that we have true length, which is a number, and that's going to be input string. Oh, sorry, this is not the full length. This is the meaningful part. So this is the 13 characters right here. So then what we want to do is we want to run the URLify on our input string. And we want to give the true length as well. And then what we just want to do is we want to check that this has replaced the spaces. So we want to do console.log input string. And I'm just going to join this back up into string again from a character array. Okay, so let's try this out. Hopefully it works. So if we run that now, we can see that we have our output right there. So we have the expected output. So we have Mr. %20 John, %20 Smith right here. So let's try this with a different string. So if we had hello world, for example, hello space world, we have a percentage here, so we need 2 more characters here. And the true length in this case is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, I think. 1, 2, 3, 4, 5. Yep, 11. So if you were to try this with hello world, we can see that it says hello %20 world now. So our function is working right there. Let's try this with 2 spaces. And then we give 4 extra characters. Let's try it like that. So it should just be %20, %20. Or maybe not. Oh, I guess we didn't give the true length correctly. Let me try putting that to 2. Yeah, there we go. It's because I panicked for a second there. I thought it wasn't going to work. But yeah, we have percentage 20, percentage 20. So this right here, I guess is our optimal solution. So I'm just going to put the original text back. And yeah, so this is our optimal solution, and it uses order S or order N time complexity, order one space complexity. Yeah, and again, this will only be possible if we were given the true length of the string. Otherwise, our best solution would be this one, which uses some extra space. So yeah, that's my solution to the URLify problem. If you come up with something better or something different, just leave a comment and I'd love to see it. So yeah, thank you for watching.